Hey, hope everyone's good and having a good time or a good holidays with friends and family. So this channel, it's primarily about vibe coding, and I'm going to be doing a lot of vibe coding live. But whenever I see some AI news that I think's worthy of mentioning, or if I see an interview with an influential member of the AI community, I like to give some commentary on it. So today I have an interview with Greg Brockman, who's the CTO of OpenAI, and Matthew Berman, who's a really great AI journalist that I recently stumbled on. And so I'll go ahead and get into the interview here.
Joining me today.
Thank you for having me. It's good to be here.
Um, I have a bunch of questions for you. I wanted to start first with scaling and specifically Sora. So Sora 2 released last week. What is it like thinking about scaling a model like Sora, and how is it different from a text or image model?
Well, I guess the way I would think about it fundamentally is that, at a broad level, everything is still just deep learning, same mechanics, same sort of underlying principles. You got to scale up massive amount of compute, a forward pass, a backward pass, gradient step. At a more detailed level, still a transformer, right? Which is actually
It
quite
is.
amazing.
Okay.
Yes, and you train it in a different way. You're using sort of a different process, much more. You think about things like diffusion, or sort of a different way of thinking about how to, sort of pour compute into these models. But fundamentally, the thing that I find so amazing is even though you're talking about text versus video.
So again, I guess what Greg Brockman is saying here, and at a very very high level, uh, I guess Sora, which is the video model from OpenAI, and also ChatGPT, which is the text model, are using the same underlying technology, which is a transformer. And at a very high level, a transformer is where you assign attention to a sentence or an image. So, like for instance, ChatGPT, you have a sentence go in. That sentence is a series of tokens, right? And then you have these attention layers that assign meaning to that sentence. And those attention layers can be something as simple as phrases inside of a sentence, or grammar, or the position of words, right? And so you run that sentence through the transformer to assign meaning to the sentence and build some sort of mathematical representation for the meaning of that sentence. Same thing with images.
Which are seemingly as different of modalities as you could expect, that you have this massive overlap in terms of the actual underlying computational process to learn and generate them. And so there's something like really, really deep about that fact.
So are you pretty bullish that the transformer architecture is going to get us to really the next level, maybe full world models, which is, Sora 2 is obviously a big step in that direction.
Yeah, I think, well, so two things. Like, one is that I think there's a lot of questions around, like, are we missing big ideas? Do we need like another innovation on the level of a transformer?
So again, world model, and this is how we need to build the world model to get to AGI, and that's my understanding. This is what I've heard many different people say. And so the world model, the interesting thing about the world model is it includes spatial intelligence, right? So you have the text model, which is predicting the next token. And Sora is I believe doing something similar, kind of predicting the next image in the video, right? So a video is a collection of image frames, and so Sora's kind of predicting that next image in the video. And so Berman's asking him, "Hey, is Sora a big step towards understanding the world model and video, or being able to build video simulations of the world could be a big step in nailing, I guess, spatial intelligence and awareness and some of these other core items that we need to get to AGI."
I think that there is lots of room for innovation, and we've seen it, right? That I think the algorithmic progress has kept a pace. We've done studies over the years to see exactly like what the curves are. I don't see those stopping. The scaling curves also continue, right? The data curves also continue, and that's the thing that has driven this revolution. Is that there's
And again, if these scaling laws were not holding, right? So they know, okay, if we bring this much compute online, and we do this big of a pre-training, we scale the pre-training run up to this level, we know we're going to get X amount of increased intelligence, right? And that's really what has brought the institutional money and some of the money from Wall Street and that venture money, into OpenAI and other companies in the space.
Multiple limiting reagents, and each one you can just keep tuning, and you'll just see the performance of the models just increase appropriately. So I think there's so much more to be built. I wouldn't be surprised if AGI looks kind of similar to the models we have today, but I would be shocked if it was exactly the same architecture.
And then when you're looking at these different types of models, although they are all transformer based, are they
Interesting. So right there, he mentions that it's not just scale that's going to get us to AGI, right? There may need to be some new technique, some new new approach, right, or some new architecture that may help get to AGI, and maybe that just means redesigning the compute to handle the workload. But definitely he's saying, hey, okay, with the current architecture, just scale is not going to get us there.
pretty significantly different in cost? And like how do you measure the unit economics of the different types of models that you're serving today?
Yeah, there's definitely different performance characteristics that sometimes we have a different inference stack associated. The optimizations are different, that different models are maybe amenable to different types of hardware, that you can really see that like the exact balance between like the memory and the compute and all those things, those can be different. So there's a lot of systems work that looks quite different at a detail level. And when you're really trying to extract screaming performance out of the hardware, that it pushes you in very different dimensions. But I think at the end of the day, we really view it as like the fundamental driver of all of this innovation and really bringing it to the world is compute. So you got to build as much as possible. And there's some specialization of.
Again, so I guess he asked him, how do you measure the cost, for these models? I guess what goes into training them, and are they all equally as demanding, or some more demanding than others? And again, Greg Brockman, and you'll hear this a lot in this interview, just kind of compute, right? Compute comes up a lot.
Different accelerators and those kinds of things. But if you zoom out, everything is just doing matrix multiplies, doing some attention mechanism, that kind of thing. And so that we do a lot of juggling internally of capacity and, sort of prioritize, 5 different demands on one person's time who can go and optimize 5 different models. It's tough, but that's what we're signed up to do.
All right, let's.
So I guess all the models are using compute, obviously, and so how do you decide how to price these? And really, kind of the elephant in the room is, hey, you just launched a social video app, right, that has this compute demand, but this demand should maybe be going to the researchers, right? And so how do you decide who gets this compute, who doesn't get the compute? How do you decide how to price the different models, right? What's the demand of the different models? Is the Sora model a lot more hungry for compute than the text model?
Let's continue on hardware. A big announcement with AMD. So is it fundamentally different to build on top of AMD hardware? Is it just, okay, now we just have this increasingly massive pool of resources we can pull, or is there like deep technical changes that need to be made?
So we've actually been investing in AMD software in many ways for a long time, right? Because we build on top of Triton. That's something that a project that we've sponsored and really helped develop, and that vast majority of our.
Okay, so Triton is some open source tool where they can replace the CUDA kernel. And I guess in this case with AMD, it's not CUDA, but they can replace the GPU kernel to try to get optimizations out of the GPU for the workload that is the LLM inferencing workload, right? Now, the thing that's really interesting about this is that OpenAI has chosen to build these massive GPU farms to handle the pre-training and the inferencing, right? But there's companies that have went in a different direction and instead built massive kind of chip wafers, right? And so we know that the GPU hardware is not the only road forward, and there is different approaches to this. And so I think one of the models, GLM, is actually running on a CPU and not a GPU. But here's Greg Brockman talking about Triton, which is the open source tool to help them get more optimization out of the GPU. And really, and I guess in my mind, there's still some question as to, is the GPU the ultimate hardware, for this workload? And obviously, it seems like there's data centers being built, and obviously there's demand for this type of hardware. But will there be another breakthrough in that space, or a better hardware solution to handle this compute?
GPUs are running Triton kernels effectively. And I'd say the way I'd look at it is that there's inference and there's training.
Mm-hmm.
There's a massive fixed cost to getting inference working. There's an even more massive fixed cost to getting training working. And we're at a point where we actually have been able to use, with a very small amount of work, to be able to use AMD software this year and get good performance out of it. And so a lot of that is enabled through just like this partnership we've had for a very long time.
So again, NVIDIA, I think, with the tech stack that they built around the hardware, really were trailblazers in this space, and working closely together with companies like OpenAI to make sure they got maximum optimization out of the hardware for that workload. But you can hear, as Greg Brockman is saying, that competition is coming. Now AMD has a solution, or they've worked together with the OpenAI team and worked on integrating Triton or other optimization frameworks onto their stack, and now they're getting the performance that they need to run inferencing. And so Greg Brockman says that. So just definitely some competition coming for NVIDIA.
Provide a lot of feedback, and we're at a point now where, from an inference perspective, we feel quite good about scaling. And there's different niches for different pieces of hardware, and that we're excited about the MI 450 series, that there's a lot of good innovation in there, and that we will also scale up a ton of NVIDIA for inference and training as well.
Do you ever consider some of the newer players like a Cerebras or a Grok, like kind of the
Okay, again, so Cerebras is the company that I just mentioned that is running models on CPUs. So there is, a different method than just running the inferencing and the pre-training on GPUs. So just something to think about.
like wafer scale computing, and do you ever consider those?
Yeah, so in 2017, we got super excited when we saw Cerebras, because it was just this totally new paradigm. You looked at the numbers, you're like, wow, like if we could have like 1 million of those things, we could build AGI, right? It's just like, you just realize it's a very different sort of platform. And I think that it's turned out that building non-GPU architectures has been way harder than we expected in 2017. But from the very beginning, we really mapped out the whole ecosystem. We tried to talk to all the different chip players and try to give them some advice, talk about here's what the shape of the workload is. And honestly, most of the companies wouldn't listen to us, right? It's like,
so again, I know that Cerebras has proven, from my understanding, that the CPU, running the workload on CPU is viable method. Brockman kind of dismisses it here, and he has deeper understanding than me, of course, about the details of this. But he kind of dismisses it here and says, hey, we've been saying from day one that it's going to be the GPU, the workload's going to run on the GPU.
2017 OpenAI was, I guess, very different than today OpenAI.
You'd be surprised, people still don't always listen.
Okay.
But I think it was, to some extent, it wasn't even that they thought we were wrong, but that if you have people who come from the chip world and have a particular way of looking at the problem and don't understand the workload, and you try to say, no, 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 this perspective is backwards, right? That you really need to think about it in this other way, that it's going to be about big models, not, small models, whatever. Those kinds of design inputs, if you don't buy into it, it's very hard to then rebase your whole worldview on top of it. And so I think that what's been,
Again, this is all big model versus small model, right? So now, and OpenAI has been going around to all of the chip makers explaining, hey, we're going to be building big models. We need to get better optimizations out of your hardware. This is what how the workload's going to be shaped, and build the hardware for it. And this is interesting because we're kind of making this big leap here to try to get to AGI, but I'm still not certain that just this increase, and I'm using the models every day for business use cases, right? I use it for personal use case, but I'm not convinced that a 10x increase in intelligence is going to, and just blazing through these benchmarks, translates to real world GDP and whatever you want to call AGI, right? But again, you can see Greg Brockman, his mind is stuck on big models, not small models, big models, not small models, compute, and then, and hey, we need to change the world. And then you get Sora, right? Which is this social cameo app. So just stuff to think about.
what's really distinguished the successful players in this space has been people who bring in people with a deep learning perspective or really try to pay attention to where the workloads are going.
And when you're looking at the entire pipeline of building out compute all the way to serving inference, where do you think the biggest bottleneck is today?
Well, I think we are heading to a world of absolute compute scarcity. And I think that we're heading to a world where energy, certainly the US, is going to be a massive bottleneck. But there's all sorts of parts of the supply chain right now that have not yet.
So again, we're, as a country, right? It seems like as the administration's aligned with OpenAI in trying to meet this mission of AGI, and this mission of AGI is incredibly energy demanding, right?
Adapted to the demand shock that we see coming. And so that's what we've been really trying to, back to us saying things continually over and over for many years now, we've been saying, hey, we need to build more compute.
Yeah, and I there's been rumors that OpenAI is.
So again, you hear that a lot. That's kind of what they're singing from the rooftop, right? Is here's the AGI mission, energy, compute, right? That's what we need. Give us more. And it's really, I still think that we're scaling based off of an approach, but the pre-training scaling is finite, right? There's only a certain amount of data available to run pre-training on. So at some point, there's going to need to be some technological advancement or some new breakthrough. And I'm not sure that just throwing more compute and getting more intelligence translates to real world GDP increase.
Developing its own chips, but do you ever see maybe investing in your own energy grids and systems, inventing new things on that front?
If you had talked, fast forward or rewind 10 years back to 2015, 2016, me, and ask what we're going to do. We're here to build AGI. And we thought of it very much as a software endeavor. We thought of it, in fact, as just we need to come up with some new ideas. We'll click it into place. AGI created. We started to find that actually it's a computer.
AGI in a safe and responsible way.
Endeavor, that is like this fundamental reagent that is much easier to scale than many other things. That's why you press so hard on compute. You have to push it to the limit.
And compute, that's the easy answer, right? Let's just throw more compute, throw more money at this. And I guess, compute is more available than technological breakthroughs, right? And because of that, we know that we can bring more compute capacity online. We know that when the pre-training rounds get larger and larger, that we're squeaking out more intelligence. But again, does that is that really translating to economic abundance? I'm still not convinced that it is.
And then you start realizing that actually there's this massive physical infrastructure build you have to do. And so we're now getting into that world. We're doing things like Stargate, starting to build our own data centers. And so I think that the where does it stop is really about what is the world willing to supply. Yeah. And so if the market does wake up to the demand that we're really very loudly trying to say is coming, not just from us, but from the whole industry, then great. Like I would love not to have to go and figure out.
Now, I think that the B2B adoption will come, and you'll see more and more enterprise companies adopting it, but I'm using it every day, and it still lacks this common judgment, right? I mean, sometimes it'll introduce a bug, you tell it about the bug, it introduces a different bug. You tell it about a different bug, it introduces the original bug, right? Where if you were sitting down with a human, they would have the judgment and the awareness to not make the mistake over and over again. So you see these kind of this extreme intelligence, you see that the model's breaking through these benchmarks, but then when you're trying to use it on these practical kind of enterprise use cases, you notice you can quickly understand, where the shortcomings are, right? And so to me, just bringing all this compute online, getting to AGI, does that unlock these business use cases, or some of these use cases that are really going to drive GDP growth? Does higher intelligence unlock that? I don't think that we necessarily need higher intelligence as not, maybe a larger context window, but I'm not convinced that it's higher intelligence.
How to build energy ourselves, but we're here to do the mission.
And so with the limited GPU, limited compute that you have now, you have a lot of conflicting needs. Consumer products, enterprise products, developer APIs, training. How do you what?
So here's Matthew's really getting into some good stuff here. So again, remember OpenAI, had a mission of being open, safety, right? Driving real value, driving real change, right? And a lot of that is tied up in research and science and technology breakthroughs, right? But recently, OpenAI has been talking, let's change the world. And then you saw Sora come online, which was a video model that they're using to build the world model to get to AGI, right? But they put a social spin on it and released it as a social app. And so the real question is, what was the decision making behind the process of you, I guess, releasing this very compute heavy workload, right? That really doesn't align with some of the mission of changing the world, right? And so how do you justify that, or how do you reason with that? Because you'll hear Greg Brockman says, it's incredibly hard to make this decision. I lose sleep over figuring out who's going to get the compute. And in my mind, if it's that critical of a decision making, I'm not deploying a mimic, an app to do a cameo of my friend and make an AI video. That's just me, though, right?
What is the conversation internally at OpenAI like when you're trying to decide where that compute investment belongs?
Pain and suffering. It's the only.
So there he goes, pain and suffering, right? He kind of Chuck giggles after.
It's the real truth. It's like it's so hard because you see all of these amazing things, and someone comes and pitches another amazing thing, and you're like, yes, that is amazing.
And you guys are doing so much. So what is I mean, we have a tiny company.
So you've got like cure cancer, anti-aging, all these incredible breakthroughs, right? And all the ideas come into the room, and then Sora, the Cameo app, that's it, right?
And we can't decide of the many things what to do. And so I can't even imagine that at OpenAI scale.
Yes.
What is that? Give me a little bit more about what that internal conversation is like.
Yeah, the mechanics more specifically. We've evolved them over the years, but right now there's Jakob, our chief scientist, and Mark, who runs research, together decide the compute allocations. But more broadly, actually, there's first a split between the research side and the applied side, and that usually gets adjudicated at sort of the Sam, Fiji, that set of people usually is making that call. And then within research.
So again, in my mind, the compute definitely, and you would hope a lot of the compute's going to research breakthroughs, right?
I just described how that gets allocated at a mechanic.
And that's more of the domain where, to me, higher intelligence makes more sense, is some of these breakthroughs. And I think maybe that's what the investors have in mind, right? Is if we can make one of these breakthroughs, one of these discoveries that we'll see payback like we've never seen before, or see returns like we've never seen before. But definitely in the research sector, to me, the increased intelligence makes a lot more sense.
Level.
In the enterprise sector, I'm not sure that we need higher intelligence as much as we need like better judgment and more common sense and better memory.
On my team, who are really dedicated to this hard task of actually shuffling around the GPUs. It's really amazing to watch. Kevin is an example. Kevin Park is someone on my team who just you go to him and you're just like, okay, we need this many more GPUs for this project that just came up. And he's like, all right, there's these 5 projects that are sort of winding down, and this one's got to finish at this point, and so we can sort of make the Tetris work. And it's just really amazing to see both the intent.
You can just imagine okay, we got a lot of demand for Sora. We got to pull a couple nodes away from the research guys, from the dudes in lab coats, and bring them over here real quick.
Part of this, of just where do we want the compute to go, but then the actual solver, and some of that is human, some of it is spreadsheet, some of it is I think it'll be very interesting to see if we get our models in there. But so I just say it's not an easy process, but I think it is just it's been very interesting to watch, because I think that compute is such a driver of teams' productivity, and so people really care that the sort of energy and emotion around do I get my compute or not is something you cannot understate.
All right, let's shift gears for a second. So you made an announcement.
Yeah, I mean, if I was a researcher trying to change the world, and I look on my phone and one of my family members made an AI cameo video of me, I'd be a little angry too. I'd want some more nodes in my cluster.
You're now bringing, lack of a better way to describe it, the web into ChatGPT. You showed off the Zillow example. As apps continue to migrate towards a more native experience within ChatGPT, how are you thinking about this decoupling of the human to internet experience that seems to be happening as agents continue to increasingly browse on our behalf?
So I think I'm going to end it there, guys. Again, just a quick video. Wanted to give some commentary on this interview, which I thought was a really great job by Matthew Berman, sitting down with Greg Brockman. And thanks, everyone. Have a great holiday.